In this video, I'll show you how to use APIM to fix these problems permanently with clear policy patterns, real architecture, and hard-won lessons. Watch this and you'll stop putting out fires and start building bulletproof APIs your consumers can rely on. Let's start with the segment number 1. Your API gateway is not doing enough. If you're experiencing these pain points, why are unauthenticated requests reaching my backend? My new policy broke all consumers overnight. Then, it means that too many teams expose Azure functions or web apps directly with only token level security or app level auth. This creates security loopholes and fragile interfaces. APIM enforces centralized authentication and authorization at the gateway. JOT validation, OAuth to introspection, IP filters, conditional logic with policy fragments. You secure your perimeter once and adapt it with versioned policies instead of sprinkling auth across 10 different apps and hoping it works. It's your API firewall. But even with good security, it can all fail and fall apart if you are sending traffic to the wrong place. Misconfigured backends is the second segment. My staging and prod environments are calling the wrong backend. Why is my caching not working? These happen because hard-coding URLs or managing config manually causes environment bleeding and chaos in scaling. So you need to use backends and named values. Define your function apps or logic apps or APIs once. Use policy-bound variables. This isolates environments, prevents human error, and makes CI/CD pipelines deterministic. Now that we have routed traffic safely, how do we prevent our APIs from getting flooded? That is segment number 3. Rate limits that actually work. If you have experienced these pain points, some users are still flooding my API even though I have applied quotas. My backend is melting under load. That means rate limits only work if they are applied at the correct product or subscription layer. Most developers apply them at the wrong scope or forget product mappings. So use products with quotas and per user throttling. Apply policy expressions for fine control. Define rate limits at the product, not API. This lets you scale for free users versus enterprise users and protect your backend without punishing good traffic. But what if you have 20 APIs and now you are copying the same logic across all of them? That brings us to the next segment. Dry out your policies with policy fragments, which means don't repeat yourself. Copy-pasting XML fragments is a recipe for technical debt and regression bugs. Use policy fragments for JOT validation, CORS, which means cross-origin resource sharing, standardized error handling, logging, and transformation. This gives you central control over logic reuse, change once, propagate everywhere. It's real policy as code. Now, let's fix what your logs are not telling you. Why you don't know why your API is failing. Azure functions are opaque unless instrumented. You can't debug what you don't log. Use inbound, outbound, and on error policies to log inputs, headers, tokens, inspect context or last error, trace latency, flow control, customize error responses. You get deep visibility without touching your backend code. APIM becomes your API black box recorder. But what if you didn't need to write any code to control all of this? That's our next segment. Policy expressions and on-the-fly control. I broke all the clients by pushing one change. If that is a symptom that you have experienced, then header management, cross-origin requests, and API evolution often require per-client adaptation. Use policy expressions to conditionally route traffic, rewrite headers, add dynamic query params, enable GraphQL or AI gateway flows. This gives you infrastructure-level agility. No code changes needed to evolve your APIs with zero downtime. And all of this is manageable through DevOps, Biceps, or GitHub Actions, so you never go out of sync again. Before we move into the crucial section of this video, if you found this helpful so far and if you think I've earned it, hit that like button, subscribe for more Azure and cloud content, and don't forget to tap the bell icon so that you don't miss out on future videos. Now, let's step inside the anatomy of Azure API management. Not just theory, but how it actually works when a client sends a request. Everything revolves around 6 core building blocks. The first building block is API, the facade between the client and your backend. An API in APIM is not your backend, it's the contract, the public-facing layer that controls what clients see. You define each operation, get, post, attach policies at operation or API level and map it to the backend. This is your versioned, secure, documented front door. The backend can change. Your consumers don't have to know. The second part, products, access control, and quota logic. You don't expose APIs directly. You publish them through products. A product bundles one or more APIs and defines quota limits, subscription requirements, approval workflow, developer onboarding. Products are how you offer tiered access. Free products 60 requests per hour, enterprise product 10K per day, and jot auth. You decouple business model from the API code. Segment number 3, backends. Decouple service routing. Your APIs need to call backend services, but you don't want hard-coded URLs in every policy. Backends are reusable pointers to Azure functions, logic apps, web apps, external APIs, on-premise services. Use them with named values to support staging or production environments or override routing dynamically. This enables DevOps safe routing, version swaps, blue-green deployments, and environment isolation. Number 4, named values. Your environment aware config store. You don't want to hardcode secrets or base URLs in XML. Named values are key value pairs. They can be marked as secrets, used in headers, URLs, and policy expressions. They are your environment variables for APIs, enabling safe CI/CD, dynamic policy injection, and config reuse across scopes. The next one is policy fragments, your reusable logic module. If you are copying jot validation, logging, or error transforms into 20 APIs, you've got a maintenance nightmare. Policy fragments let you define once, reuse everywhere and anywhere. Policies can be used for shared error handling, course rules, token validation logic. Its dry principles apply to your API gateway, versioned, testable, and modular. The next one is tags, metadata that powers search, deployments, and automation. In large teams or enterprises, finding the right API or managing deployments is painful. Tags help in grouping APIs, example finance, internal, version 1, etc. They filter APIs in pipelines, automate deployments via bicep or transform. They don't affect traffic, but they make governance, DevOps, and documentation effortless at scale. Let's put this all together. Serving a real client request. When a client sends a request, say get orders, the APIM engine kicks in like this. It routes the request via the API contract, checks the product, applies quota or subscription logic, applies inbound policies, auth headers, logging, etc., routes to the correct backend using named values, backend returns the data, outbound policies modify or secure the response, and only then the response reaches the client. What feels like one API call is a policy-driven, rule-governed orchestration layer. That's what makes API management essential for teams that care about security, consistency, scalability, and sleep. Now, I'd like to know what is your biggest challenge while developing, deploying, or governing your APIs. Please feel free to share in the comments below. Okay, now I want you to recall or remember if you have ever asked yourself, why are unauthenticated requests still reaching my backend? Some users are flooding my API even though I set quotas. Why am I copying the same XML logic across every API? Why isn't my caching working? Why did my API response time spike from 150 milliseconds to 800 milliseconds? If you have asked these questions, then you cannot miss my next video. It's that video that turns chaotic, fragile APIs into bulletproof, maintainable systems, and it's built for real-world scenarios you face every day. So click through now and let's take your API management game to the next level.